Hello everyone, my name is Karan and I am a data analytics intern at the Sparks Foundation. Right now I'll be performing the 6 tasks of the internship, which is the prediction using decision tree algorithm, and we'll be creating the decision tree classifier and visualizing it graphically. And the purpose is, if we give a new data to this classifier, it would be able to predict the right class accordingly. So it's a sample dataset available in the Google Colab notebook in Jupyter notebook, so you can download it from here, or you can get the available data over here on this website link. First of all, we'll be importing the libraries. Required libraries have been imported, and including the algorithms and models required using the scikit-learn. Then after importing the data set and performing the required necessary steps to get the non-null count and the data types of each of the four columns are over here. Basically, sepals and petals are the parts of the flower, and based on that sepal width and length, we'll be categorizing the species which it belongs to. So there are about 3 unique species: Iris cystosa, Iris vesicolor, and Iris virginica. So these are the 3 unique species based on the sepal length and width, and sepal and petal length and width. We can be categorizing the species. Then we perform the statistical analysis to get the sepal length and sepal width, their sepal length and sepal petal length and width, their count values, their mean, standard deviation, minimum and maximum values. Okay, now we perform the exploratory data analysis, which involves a pair plot that basically shows the KD plot and the scatter plots relation of all the numerical values of the petal and sepal length and width. So Iris cystosa has the smallest of petals width and length, and it also has the smallest sepal length but largest sepal width. Then we plot a heat map showing the correlation between the numeric values. So petal width and petal length features are highly correlated with each other, and sepal width and sepal length features are slightly correlated with each other. Now this is a category plot for the 3 species based on their petal length in centimeters. So Iris virginica has the about highest number of petal length. So this basically categorizes the 3 species on the while we plot them in the graph. Next again is the scatter plots for petal width and petal length based on the species. We see that Iris cystosa has the smallest of all petal length and petal width, whereas Iris virginica has the highest length and width of petals. Then again we do it for sepal length and sepal width, and we observe that sepal length is smaller and sepal width is higher for Iris cystosa, whereas Iris virginica has medium sepal width but about higher sepal length. So Iris versicolor lies in almost middle for sepal length as well as sepal width, and Iris virginica has larger sepal length and smaller sepal width, and Iris cystosa has smaller sepal length but higher width. So now we'll be plotting the box plot for the sepal and petal length and widths, categorize them both on the species in order to view what is the range of length or width values in which the specific species lies based on centimeters, in which range they lie. So iris sestosa has the smaller feature and less distributed with some outliers, and iris versicolor is distributed and has the average feature. Iris virginica has the largest feature and highly distributed. Splitting, then we'll be mapping them accordingly by performing ordinal encoding, assigning 0 for iris sestosa and 1 for iris versicolor and 2 for iris virginica. So accordingly there are total about 150 values in the data set. So these have been performed accordingly and they have been assigned the values, 50 values for setosa and 50 for versicolor and 50 for virginica. Then we'll be splitting the data. Our species column will be assigned as the target variable, which is denoted by y, and rest independent features, the sepal and petal length and width, will be assigned and denoted by the x. So performing a test and train splitting, we get the number of unique values of both y train and y test. Then we perform standardization under feature scaling to make our models perform better. And creating the decision tree model, we try to fit the model then with the x train and y train data available after train test splitting. Then we make a prediction on our test data. Over here we have the accuracy of 93.33% when we compare the y test with the prediction values. These are the classification reports we observe. Then in order to get more accuracy and to be more satisfied with our model fitting and prediction technique, we perform the hyperparameter tuning using grid search. So this is what we have done, and after that we try to make a final decision tree model in order to check whether the hyperparameter tuning has made a proper and correct and accurate predictions or not. So after doing it again, making the decision tree model, we get the text representation over here, and then in the end, with the feature columns and the target classes, we then get the decision tree as follows. So this is it with the explanation of the prediction using decision tree algorithm. Thank you.